Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Bosch DS151I. This is a sensor, is what it is. This unit is in particular intended to be used as a request to exit sensor, and you'll very commonly see these installed when you have a single door or a pair of doors with an electromagnetic lock. And as you approach the door, obviously the sensor is going to open the circuit to the electromagnetic lock, allowing you to exit. Is very common. There are other requirements for openings like that per code, which would be a switch. Well, it'd be a switch, but it would just be a push button within, I believe, 60 inch of the opening that is directly wired to the magnetic lock to open that circuit in case the sensor failed. So that's a requirement for an opening like that. But you'll very often see exit motion sensors used in those applications. You obviously need some other type of hardware. I commonly see it with just a horizontal push bar. You might have a touch bar that may incorporate the request to exit switch in it. But in terms of a sensor, this would be an option. Now, the Bosch is available in the DS151i, which is the black version. And then you can do the DS150i, which is the white color. Everything is obviously identical otherwise about the material. So it's going to include, of course, the sensor itself. Let's take some dimensional properties of the item. Overall width. Looks like it's about 6 5/16. Overall height, about 1.5 inches. Projection from the wall, or from the header, possibly, just about 1 7/16 inches. Okay, removable cover. Now, some extended description information is down below, which we'll get to. It's going to have, of course, its cable, which we will identify through the installation instructions that we'll touch on in a moment. We'll also give you a couple of screws and plastic anchors, and we'll also give you some inserts. Okay, and that's to help refine the field of activation, so to speak. So let's switch to the screen view where we can take a look at the supporting documentation. Okay, so this is the item that we're looking at, and you know, it's a really smart device. It's going to be really capable of handling the requirements of what it's intended to handle as a request to exit sensor, and does so almost without any theoretical flaw, and we'll go over that in a moment. Single or double door use, wall or ceiling mounted, and they like the ceiling mount very much, and we'll get into that. Internal vertical pointability. You can move the sensor to adjust the coverage on the floor. Wraparound coverage pattern. 12/24 AC or DC operation. Up to 60-second. It's actually 64-second, I believe. Adjustable latch time. Selectable relay trigger mode. Selectable fail-safe or fail-secure. UL listed. CE approved. So there is a link below this video to the installation instructions, and let's dive right into those. And we'll probably hop back to look at some other items, and let's go over it. The DS150i or the 151i, just different colors. A PIR, passive infrared detector, designed for request to exit, or what we call REX or REX, a REX switch. UL listed, access control device, compliant with UL 294 standards, and is listed for Class 1 UL Canada applications. You're going to want to make sure that you're connecting it to other ULC S319 devices as well. So the relay output consists of two Form C contacts, just two single pole double throw contacts, and we'll get into that in a moment. That can be adjusted to latch between 1/2 of a second and 64 seconds. Okay, and the latch timer features two modes of operation, resettable and non-resettable. And we're going to discuss that, but it basically means after the countdown starts, what happens when additional motion or really change in temperature is detected? Does it march through to the end of the timer, locking it out? Or does it march through the end of the timer? Or does it restart the timer back to 0 and then march through the timer? The relay can also be programmed for fail-safe or fail-secure during a power loss. You know, fail-safe is going to be standard operation, where upon loss of power, the sensor is going to unlock the typical electric strike, and more usually the electromagnetic lock. You can mount the unit on the ceiling or the wall, and you can mask its pattern because there are a couple of blinders. There's a term for them, I forget what they call them, but we'll get to that you can snap over the sensor field, or over the sensor itself to tailor the field. You can do it in light gray, which I've been calling white or black. And there's a trim plate, which is here. We'll just scroll down to mounting. We're going to go down this side. Select a mounting location over the center of the door or doors to be covered. The target must walk directly toward the detector. Mount the detector on the ceiling, wall, or the header of the frame. The detector can be surface mounted or mounted to a key switch plate with a D-sized hole. You may want, because the sensor itself is not going to cover a single gang box, you may want that trim plate, which would be really nice because the trim plate gets attached to the box, the sensor gets attached to the trim plate. The arrow on the base indicate its correct mounting orientation relative to the door. The mounting height is between 7 and 15 feet. Remove the back cover from the detector. Insert the head of a small straight-edge screwdriver into the locking tab and pry the back cover off. Let's switch back to the camera view and take a look at removing the cover. Now they say to insert a flat, small screwdriver into it. I find screwdrivers are always really too fat, too thick, and they really force you to spread the material. And really small screwdrivers just aren't wide enough. And believe it or not, I always just use the tip of this style of cutter, and I don't break these tips off because they don't really break very easily. And that's the area right there that you're going to insert it in. Down here there isn't one. So when I get that put in there, I can just gently move that, and I don't scratch anything. I don't scar anything. Anyway, that's the tool that I use to pull those covers off. Hey-o. Okay, so you've got your mounting plate basically. Then you've got the business end right here. Okay, and that's all. Then you've got the cover. And that all will go back together just the way it came. Quite simply and straightforward. And it will only go back together one way. So, and what I mean by that is a couple of small prongs here on this side. Well, actually, they're on both sides. And I find that it snaps together relatively easy. Okay, so I just had the internal body moved a little bit. Now, you can obviously notice what I'm adjusting here as well. So let's get that back. Actually, what we'll do is we'll wait. I just wanted to demonstrate removing the cover. We'll wait until we get to that part where we can trim the orientation of the sensor relative to the pattern on the floor. So let's switch back to the screen view and continue on with the installation instructions. Okay, as we continue on through the installation instructions, when the back cover is removed, the front cover and detector module separate. So there are three pieces, as we demonstrated earlier. Route the wiring as necessary through the wiring entrance. Refer to Figure 2. Figure 2. So, yeah, there is a wiring entrance that I do need to show you. Let's switch back to the camera view. Now that wire entrance, or that prep, when we separate the the mounting plate. Just going to tug it out. You can see right here. Now, this area right at the tip of my finger, you can see how it changes the color a little bit. That's very thin, and you're just going to knock that out, so to speak. That is meant for you to, you know, carefully, probably with a tool like this, cut that little notch open so that your wiring can come out through either end of the unit. Okay, so that's what the wiring entrance is called. Let's switch back to the screen view. Okay, so figure 2 showed us the wiring entrance. Loosely mount the back cover to the mounting surface using the supplied mounting screws. That was the mounting plate that we showed you earlier, which, you know, is this piece here. Mount the detector module to the back cover. Aim the detector to the desired coverage. And that's where we had demonstrated earlier where we can rotate rotate the way in which the sensor is pointed. Okay? And that's what you're going to do to detail your coverage. Figure 2, wall mount angles. Now, the wall mount angles are on the curved module assembly itself, okay? And you'll be able to rotate that to, you know, give you a negative 14 degree, a 4 degree, and then a 14 degree, you know, sort of position from horizontal. Your dip switches, your wire plug, your LED, and the ceiling mount angles are on both sides. Now, wiring, this does include, of course, this 8-pin connector. And the relay contact wiring is where they get into immediately. So you're going to plug your connector down to the board itself. That's simple and straightforward. Now, they had mentioned that there are 2 Form C relays, single pole, double throw. So, depending on if it's fail safe, you'll use this column. If it's fail secure, you'll use this column. So, quickly, a fail safe environment is where the hardware, on the absence of power, the circuit is open. Meaning there is no power energizing the circuit because the circuit is open. Fail-safe means that upon loss of power, the lock is unlocked, is what it means. Fail-secure is the opposite. It is a normally, fail-secure is when on absence of power, the hardware will automatically be locked so that you would need power to unlock. That might be intermittent or temporary, or it might be long-term. But when you open the circuit temporarily, regardless of the duration, that hardware is going to fail in a secure or locked condition. And you can study how the drawings are the same, but you'll notice the normally closed and normally open legs are reversed. Okay. In a power-off condition, this is what your Form Cs look like. In a normal operation, when there's no motion activated, this is what they look like. So, you have a normally closed circuit in a fail-safe condition with no motion. You have a closed circuit, so power is moving. I would imagine you're going to be locking something in that condition. When you have motion, it will open the circuit, allowing your hardware, which is fail-safe, when you remove the power or open the circuit, that hardware will fail unlocked. By the same token, the fail-secure, when there's no power, the circuit is, let's just say, normally closed. There is no power to it. When you are in the off condition. When you have power, okay, you have a closed circuit, which might be unlocking the lock. When you have motion detected, you will open the circuit and unlock something that's happening there. So this would really apply to a magnetic lock, where when you have a fail secure condition, probably not best for a magnetic lock because that's going to fail unlocked. But when you have a piece of hardware that's fail secure, no power, it's locked. When you've powered it but there's no motion, it's locked. When you have motion detected, it's going to open the circuit, allowing you to reverse the fail secure condition to being unlocked. So for the amount of time that motion is detected, you have an unlocked lock, is what it is. Let's move to page 2, 3.2. And here we continue with the discussion of the pins 6 through 8 and pins 3 through 5. 6 through 8 is a spike-protected relay. Use this relay when connecting inductive loads to the detector. This relay protects the detector from inductive loads that might deliver damaging EMF spikes. 3 to 5 comprise the non-EMF spike-protected relay. Figure 3. Okay. Most likely you're going to be using a magnetic door lock with this. You simply want to make sure, if you are, that you are going to be operating it. If you happen to require a bridge rectifier, you would use that. And you want to be sure that your magnetic lock is UL 1034 listed, EMF spike protected. Okay. I don't think you're going to, installing a bridge rectifier is probably not going to be necessary at all, as long as you have compatibility of the components that you're connecting to it. Speaking of connecting to it, here's the configuration. The dip switches are here listed. There are 6 switches. Let's go through them. Dip switch 1 is the resettable or non-resettable timer selection. And basically what that means is, as I had said earlier, a resettable means that the relay activates upon first detection. Any additional motion restarts the timer and deactivates only based on your switch 4, 5, and 6 for time delay. Okay. I don't think that this is going to be a typical application where it's resettable, where motion will continue to unlock it. Every time that I see a sensor like this on access control is non-resettable, where the relay activates when the detector first sees motion, and then the timer runs, and at that point it will go back to its normal pre-configured condition. And that's listed here as best used in access control systems. Even if there is still motion, it will lock the door. So depending on your application, you'll have to go resettable or non-resettable. Non-resettable, I'm quite sure, is the standard. Forgive me, resettable is the standard. That's the default setting. That's listed in Table 1. Now, relay mode is what we had talked about earlier about fail-safe or fail-secure environments. So we won't go over that here, but that is controlled on dip switch 2. I guess we'll go over it. Fail-safe is in the event of a power loss, the Rex detector releases the device connected to it, like a magnetic door lock. That would be pretty typical, because magnetic door locks, or anything locking the door upon loss of power, they're unlocked. So opening the circuit to a mag lock or to an electric door strike would be fail-safe when it's unlocked on the absence of power. Fail-secure is the opposite, or I shouldn't say the opposite. Fail-secure in the event of a power loss, the Rex detector does not release the device secured to it, for example, a magnetic door lock. In fail secure mode, the REX detector shall be installed in a manner that does not impair the intended operation of panic hardware used in conjunction with a REX detector. So fail secure mode must be authorized. So fail safe is absolutely default. What they're saying here is, in the event of an emergency, you have to be able to get out those doors, regardless. If power drops, say from the fire alarm panel, it needs to be unlocked. So fail safe is going to be the default configuration. You know, other occupancy types, let's say detention work, they have their own requirements in NFPA 80 and NFPA 101. NFPA 101 really would be the standard that would define different occupancy types. So fail-safe is going to be common. When you walk up to a door to exit, it has a sensor. It opens the circuit. The mag lock drops out because power has been removed. It's unlocked. And when the door closes again, the timer will go through its time. It will then close the circuit, re-energizing the magnetic lock. You want that to happen when the fire alarm panel communicates to the hardware and says, drop out. Everything is unlocked. Doesn't mean unlatched. So if you had an electric strike with a lock on it, you know, provided that met your egress requirements, meaning if the trim on an exit device or a mortise panic device, you'd still be latched, just because you don't have to use a magnetic lock with this where your door is actually unlatched. You can have a fail-safe piece of equipment where it's latched, but it's not locked. So that would be the difference there. An example of that would be stairwells in high-rises, where those doors must always be latched because they're fire doors, but they want them to not be locked in the event of an emergency, and all of them, in fact, simultaneously. Dip switch 3 is whether or not the LED will activate. You may or may not want anyone to see that operating. I can't tell you why or why you wouldn't, but you can control that. Then your dip switches for reset or re-engagement of the material are listed here, and just depending on how you set the switches will give you from 0.5 to 64 seconds. Let's move on to step 5. So the setup and testing portion, once you have it wired and your dip switches are correct, apply power. Wait at least 3 minutes for the detector to settle, and you're going to simply test the unit by walking directly through the coverage area toward the door. Aim the detector up and down if necessary to obtain the proper coverage. Tighten the screws after aiming the detector. Let's see. And it may not be completely obvious what they mean by tighten the screws once you do that. So let's switch back to the camera view quickly. So your mounting screws that are going to be used to get the plate installed, well, there's a saddle that's here, and that's going to go right over. So let's just focus, let's focus here. As you rotate that up and down, you're going to tighten the screw that goes through there, allowing you to secure that in the position that you want. So that's where that's going to happen. Okay? Let's get back to the screen view and continue on. Check that the relay latch time is sufficient, adjust if necessary. After confirming proper operation, replace the cover and walk test one more time to ensure coverage has not changed. Now there's some additional information that they're going to talk about in terms of masking your pattern, and then a couple of tips, actually, application notes they call it. So there are those two small gizmos here, wedges I think they call them, yeah, masking wedges. And you're going to snap those into place to kind of allow you to tailor the installation. I haven't snapped them into place because I want the client to be able to do that, but they have a couple of small tangs that you're just going to get in position, and yeah, okay, well, I snapped it into place. They snap very easily into place, in fact. And the fact of the matter is the little dimples that receive those tangs are so small that they're hard to see. And I will, if I don't forget, I'll show you those. But you snap them here and here, and then you can move them to detail, your sort of coverage. Now, what you're going to want to think about is with these sensors is how broad of a spectrum, how broad of a pattern do you want to get to? You might have something that occupies this space all the time, and your door, is really just in here. If it's a 3-foot wide door, or let's just say it's a pair of 3-foot doors, and it's gonna occupy this area here, you're going to want to mask that off. Let's say there might be a chair that sits here and someone might sit down and swing their leg over. You really don't, I think you see my point. If it was an exterior application, which you would not use this for at all, you might have a planter that sits here. If you were doing high energy automatic doors like sliding doors or swinging doors, probably sliding doors, you may have, let's say it's your local home improvement store, you might have stuff out here. Let's say it's a planter with some small trees or plants. Well, the wind's going to grab that stuff and move it, and it's going to cause false readings on that. So tailoring or masking that off is what you're really trying to accomplish. And obviously, when you are at -14 all the way down, you're going to draw that down out to just 5 feet. And when you're at +14, you're going to be out to 15 feet out. So you're going to normally be right in this range, 10 feet before, that kind of thing. But you'll tailor that, as mentioned earlier. Here are your patterns, and they indicate letter designs for these patterns, which allow you to understand when you're at 14 degrees versus -14 or below the median size, how you're going to change that, and what your pattern is going to look like as you change that. You'll have fields that will overlap each other. Now, the application notes basically talk about, well, let's just go through it. Double entry doors without a center post present a problem resulting from a gap that might exist between the doors. While the gap is usually filled with soft or pliable weather stripping, there is an opening that vandals can use to insert an object, such as a comb or ruler, through into the coverage pattern of the detector. If the object is of a different temperature from the background, it's going to interpret it as motion. So what they're saying here is, in a pair of doors, as they have drawn here, you're probably going to want to drop out your K and L and your A and B if you were to go to a 2-sensor sort of pattern. So you want to basically reduce to as close to 0 the ability of someone sticking something between the doors to create a condition that the sensor is activated. Okay, and that would be very possible because you could easily have a building that is locked from the outside, that you have a magnetic lock and you have a push bar or an exit device, and you have a sensor and then a wall push button. If I stick something between those doors, I can probably activate that sensor, allowing me to get in. Okay, that's what they're talking about. The DS1, so you can ceiling mount it and away from the door. Although, if you were to ceiling mount, you do reduce the trouble of someone sliding between here, but they're saying it can still be done. Dual mount, if you want to serve the ultimate installation even better, again, maybe install 2 of them. Okay, and you'll drop out, you'll mask off K and L and A and B on those detectors. And that's what that masking wedge, they call it. Electrical characteristics, which I won't cover here. So with the exception of the sensor being susceptible to the fact that it's a sensor and people in the know being able to detect it, which you might then want to not have your LED active at all, it is a super simple, robust, reliable, and predictable piece of equipment. Okay, let's wrap up this video on camera. Now, it's this tiny little wedge that you will literally take and snap into place. Okay. You can carefully remove that out and it doesn't damage the piece. It'll snap right back in. And there's one for each side. Right here and right here is where that is. So simple and straightforward. Now, sensors are used, you have to be mindful of what code or what ANSI standard you're very likely obligated to be held accountable to, depending on how you install a sensor. So if you have an automatic door that does not have a sensor installed, that would be considered what they call low energy. But as soon as you add a sensor to an opening, if you have an automatic door, and you can use this on an automatic door, you have a high energy, which means you have to comply with a different ANSI standard for all of the details as it pertains to the requirements of that type of opening. And there are two, and this is admittedly a bit outside of probably what you're going to use this for, but I can tell you, not this client. This client is definitely using these on automatic doors, there's no doubt. So I see these sensors installed in applications where it's just simply a door that's locked with a mag lock, you walk up to it, the sensor drops out the power, you exit. From the outside, you can't get in because that's not the entrance they want you coming into. The other is where you have automatic doors. Automatic doors are classified solely, they're classified low or high energy based on whether or not there are sensors. If you have an automatic door and you do not have sensors, the document that you're going to want to look into is the ANSI document A156.19. That would be the American National Standard for Power Assist and Low Energy Power Operated Doors. Low or high energy has nothing to do with the motor, the controller, etc. A door that's meant to be cycled thousands of times a day will be built more robustly than a door that has an operator on it intended for handicap compliance alone, sure. But that handicap compliance alone doesn't have a sensor. And when you have a sensor, you change the environment in which we are expecting the door to work. So our perceptions, our subconscious perceptions on using the door is different when I'm using a wall actuator to have the door tick open so that the handicapped user can access the building. If you have an automatic door and you have sensors involved, now your document is A156.10. That would be your high energy. And they're different in the sense of what the requirements are. And the high energy stuff is far more involved. But like this gentleman who is a college, a school, I don't know that it's a college, purchasing this material, you'll want to absolutely have available to you the A156.19, forgive me, the A156.10 standard, that's high energy, so that you can make sure that your openings are compliant. Your decals, your signage is in the right place. They operate correctly. That the amount of time it takes for you to move from here to here if you've got two doors that are staged is code compliant. So just word to the wise, there's more to automatic doors or doors that take sensors than it seems. But once you've read the documentation, in my case, read it 3 times, then you have an expert level understanding of it and you can make it thoroughly compliant, thoroughly capable of serving the needs of the users safely. I like this Bosch little gizmo. This sensor is inexpensive, it's robust, it works, it's easy to understand, there's not a lot happening. The first time that you go through it and configure it, all the other ones you do will just be like falling dominoes. Any questions on the Bosch DS151I or the DS150I? Request to exit passive infrared motion detector or any other Bosch product, please feel free to reach out to us. And thank you.